Hey guys, this is the full review for exam 3. It covers a lot of unit 3, which is chapter 5. Um, this review is really comprehensive. If you're looking at the PDF that I used for this video, you can just scroll through to whichever questions you have. You can go over the whole thing if you want. Um, it's a lot more in depth than the actual exam will be, but if you can do all of these independently, you are ready for the exam. Let's get started. All right. Question 1 asks us to graph the parabola and fill in the blanks about the vertex and any intercepts. I start with finding the vertex because that's how I graph it. So in this format, y equals negative x parentheses x minus 1 close parentheses squared plus 4. We are looking at f of x equals a multiplied by the quantity of x minus h squared plus k. And our vertex is always h k as our x and our y. Good? All right. So in this case, we have f of x, which is the same as y, negative. So our a is just a negative. I'm going to put 1. You don't have to. X minus 1 squared plus 4. So we see that our h is, notice that there's a negative in the equation itself. So our h is a positive 1 because that negative is part of the model equation. So h is 1, k is 4. That's from here. This is from here. Means my vertex is 1, 4. So h is my x value, k is my y value of the vertex. Over 1, up 4. Good? Put those right there. It's also asking for the y-intercept, so that's the first point I'm going to find. So for the y-intercept, for any graph, you just make x equals 0 and find y. So we had y equals negative 1 times x minus 1 squared plus 4. I'm going to put in a 0 for the x. Y equals negative 1 times 0 minus 1 squared plus 4. 0 minus 1 is just negative 1 squared. Don't multiply negative 1 by negative 1. Do the negative 1 squared first. Negative 1 times negative 1 is a positive 1. So we have negative 1 times 1 plus 4. Negative 1 times 1 is a negative 1 plus 4, which is 3. So when x is 0, y equals 3. So my y-intercept is the point 0, 3. They already gave me the 0, so I'm just going to put a 3 right here. Graph that. 0 up to 3. Remember that this is my line of symmetry. So from the vertex, if I went down 1, left 1 to find one of the points, I can also go down 1, right 1 to find the other point. Good, and that is graphed. That is enough information to graph the parabola. Question 2 asks us to graph the parabola, then fill in the blanks about the vertex and any intercepts. Same exact question, okay? Just a slightly different equation. Not even that different an equation. The only difference is that 3 was a negative 1 previously. So we have y equals, or f of x equals 3 times the quantity x minus 1 squared plus 4, right? And we need to find h, and we need to find k. And then our vertex is going to be HK. What is H? H is 1. What is K? K is 4. So our vertex is 1, 4. Over 1, up 4. Our y-intercept, again, we're going to put in 0 for our x and find y. Y equals 3 times the quantity x minus 1 squared plus 4 when x equals 0. Y equals 3 times 0 minus 1 squared plus 4. Negative 1 squared is just 1. Three plus 4, which is 7. So when x equals 0, y equals 7, giving us the point 0, 7 as our y-intercept. There to give us the 0, let's put in the 7. Line of symmetry, I went up 1, 2, 3, left 1. Now I can go up 1, 2, 3, right 1. My parabola is graphed. Question 3 asks us again to find the vertex and any convenient point to sketch the graph of the following function. Notice they're not asking us to write in the vertex, but you still need to find the vertex in order to be able to graph it, right? So y equals negative x squared plus 6x minus 13. Ax squared plus bx plus c means that a is a negative 1, b is a 6, which looks exactly like a b because of my handwriting, and then c is a negative 13. Make sure you include that sign. Good. And then to find the vertex, first we find the x value of the vertex, which is negative b divided by 2 times a. Input those values. So we have negative 6 divided by 2 times negative 1. We're out of space. X equals negative 6 divided by 2 times negative 1. That just simplifies to negative 6. 2 times a negative 1 is a negative 2. Negative 6 divided by negative 2 is a positive 3 because a negative divided by negative is a positive. So our x value is 3. Good. Input that into the original equation, negative x squared plus 6x minus 13, to find the y, and that will give you the other point of your vertex, the other value of the point of your vertex. Y equals negative x squared plus 6x minus 13 when x equals positive 3, positive 3. Y equals negative 3 squared plus 6 times 3 minus 13. Notice that the 3 is inside the parentheses, the negative sign is outside the parentheses, so the square is only squaring the positive 3, not the negative, okay? That negative sign remains. 3 squared is 9. 6 times 3 is 18. Good. Negative 9 plus 18 is a positive 9 minus 13. 9 minus 13 is negative 4, right? So when x equals 3, y equals negative 4. So that's my point. 3, negative 4 as a vertex. 1, 2, 3, 1, 2, 3, 4. I have found the vertex. any convenient point to sketch the graph. This means it's up to you. What do you think looks like an easy point to find on this parabola? Okay. You could think, okay, that's the vertex. I'm just going to go 1 to the left and find x equals 2, or 1 to the right and find x equals 4. I could go all the way over to x equals 0 because that's easy to do mathematically, right? But it might not be on the graph because we only have 1, 2, 3 spots to go down. But if I were to, what is y when x equals 0? Y equals negative x squared plus 6x minus 13, negative 0 squared plus 6 times 0 minus 13. That's 0 plus 0 minus 13, negative 0, sorry. So y equals negative 13. So that point would be the point 0, negative 13. The problem with that is that's not graphable in XYZ. So might need to pick a closer point. You can pick 1, you can pick 2, you can pick 4, you can pick 5. Pick whatever you would like. Okay. I'm going to pick 2 just because it's more likely to be on the graph. So when x equals 2, what is y? The negatives outside of those parentheses. Negative 4 plus 12 minus 13. Negative 4 or 12 is 8 minus 13, which is negative 5. So that gives us the 0.25 over 2. Oh, sorry, negative 5. Over 2 down to negative 5. If I go down 1, left 1 on my axis of symmetry, I can also go down 1, right 1 to get the other point. And you are done. Question 4 asks us to use the parabola tool to sketch the graph of the following equation. So similar question. Y equals x squared minus 4x plus 5. We need to find the vertex. The vertex, the x value is equal to negative b divided by 2 times a. A is 1 because there's nothing in front of the x squared. B is negative 4 because of that minus sign. C is 5, right? So x equals negative 4 divided by 2 times 1. Because negative 4 was our b. But that should really be that. That shouldn't have been highlighted green. And then 1 is our a value. Simplify that. We get negative 4. It's like negative 1 times negative 4 is a positive 4. 2 times 1 is 2. 4 divided by 2 is just 2. So our x value is 2. And then we input that into y, or sorry, into the equation to find y. Y equals x squared minus 4x plus 5 when x is 2. Y equals 2 squared minus 4 times 2 plus 5. 2 squared is 4. Negative 4 times a positive 2 is negative 8. Negative 4. 4 minus 8. Yep. 4 minus 8 is negative 4 plus 5 is 1. So when x equals 2, y equals 1. Our vertex is 2, 1. Find any other point on the graph to sketch the graph. This is positive, right? So I think we can make it all the way to 0, and that's always the easiest one to put in for x, right? Y equals x squared minus 4x plus 5 when x equals 0. So we're trying to find the y-intercept. You don't have to find the y-intercept. You could find when x equals 1, when x equals 3, when x equals 4, whatever you would like, okay? 0 squared minus 4 times 0 plus 5. 0 squared is just 0. 4 times 0 is 0. 0 minus 0 is 5, so y equals 5 when x equals 0, so that's the point 0, 5. Good. For question 5, find the coordinates of the vertex and indicate whether the vertex is the lowest point or the highest point of the graph. We don't have to graph anything. We're just finding the vertex again. Y equals negative x squared plus 2x plus 3. And we're using the model ax squared plus bx plus c. So that means a is equal to negative 1. B is equal to 2, and C is equal to 3, right? To find the vertex, x is negative B divided by 2 times A. Negative B is a negative 2. A is a negative 1. So that's negative 2 on the top. The numerator, the denominator is 2 times negative 1, which is a negative 2. Negative 2 divided by negative 2 is just a positive 1, because a negative divided by a negative is positive, and then anything divided by itself is just 1. So we know the x value of the vertex. To find the y value, when x is 1, y equals negative x squared plus 2x plus 3. One squared is 1, negative 1 plus 2 plus 3. Negative 1 plus 2 is 1 plus 3, which is 4. So my vertex said that x is 1. When x is 1, we found y, and we said that y is 4. So my vertex is 1, 4. Then is that vertex the lowest point or the highest point on the graph? Okay. That we need to know what direction the parabola is going, right? We know it has a vertex, but is that parabola opening up, like a cup, or is that parabola opening down like a frown, right? The parabola opening up means that the vertex is the lowest point. The parabola opening down like a frown means that the vertex is the highest point. Good. So in this picture, the vertex is the lowest point. In this picture, the vertex is the highest point. How do we decide whether the parabola is opening up or down? You look at the leading term. Here, the leading term is negative x squared. If that leading term is negative, it's opening down. Let's write this down. All right, in this case, vertex is lowest. Here, vertex is highest. Right? All right. If the vertex is the lowest point, that means that A is positive. A is greater than 0. If the vertex is the highest, that is a negative leading term, aka A is a negative number or A is less than 0. Okay, and remember, we already did that. We said ax squared plus bx plus c, so this is our leading term. Our A is a negative 1, so it has a negative sign in front of it. It's going down. That's a negative A. This is a positive A. For a negative A, the vertex is the highest. For a positive A, the vertex is the lowest. Would you say that that A for question 5 is negative or positive? It is negative, so the vertex is the highest. So that's a complicated question, but if you have this idea that if it's a positive equation, it's opening up like a cup, or it's going up and it's positive. If you have a negative equation, it's going down like a frown. It's always going down in a negative direction. Vertex will be the highest point if it's a sad face. Vertex is the lowest point if it's a happy face. All right, question 6 is the same. For the equation, find the coordinates of the vertex and indicate whether the vertex is highest or lowest point of the graph. All right, for the next one, find the coordinates of the vertex, indicate whether the vertex is highest or lowest. Same thing. So we'll find the vertex. The x value is equal to negative b over 2a. Here, what do we have? We have a is 1, b is negative 2, c is negative 15. And right now, with just the information of a, b, and c, you can answer whether it's the lowest or the highest. I'm going to jump to that just to feel like you've practiced it. So lowest or highest, how do we decide? If it is the lowest point, it's going to open up like a cup. So we're going to have a positive A. If it's the highest point, it's going to go down like a frown, and that will always be a negative A. Right now, our A is 1, so 1 is a positive, so that means that the vertex is the lowest point. Lowest, because we have a positive A right here. That number is positive. It's the lowest point because it's way down here, and the other points go up forever. Doesn't leave us any room to do with vertex, but I do feel like this is the confusing part, the part we've practiced least. So I just wanted to let you know that all you need to do that part is to look at the equation. If A is positive, that's your lowest point. If A is negative, that's going to be your highest point. So to find the vertex, x equals negative b over 2a, negative 2, divided by 2 times 1. Negative 2 leads us to a positive 2. 2 times 1 is 2. So that's just a 1. 2 divided by 2 is 1. Now to find y, x equals 1 in the equation, y equals x squared minus 2x minus 15. 1 squared minus 2 times 1 minus 15. 1 squared is just 1. Negative 2 times 1 is negative 2. 1 minus 2 is a negative 1 minus 15. Oh, this can't be right. Oh, yeah, it can because we don't have to graph it. Negative 1 minus 15 is a negative 16. Y is negative 16 when x equals 1. This we got from here. And so our point is, our vertex is 1, negative 16. Good. And we already did lowest or highest. It's opening up, so it's our lowest point. All right, question 7. A company finds that it can make a profit of that amount of dollars each month by selling X number of patterns according to the formula. How many patterns must it sell each month to have a maximum profit? And what is that maximum profit? All right, so when we're talking about profit, we're talking about money, right? And then the other option is patterns. So we have a Y value and we have an X value. One is patterns, one is money, right? They make a profit of P dollars. So profit, or the money, is our Y value. And patterns, the only other option, what are they selling? They're selling patterns, is X. Okay? What is the most money they can make? How big can we get Y, right? And if we think about a parabola is either doing this or doing this, right? And if we're talking about something you're making, you're probably starting at, I have 0 of them. I make 1 of them. I make 2 of them. My bad at parabolas, as you can tell. I make 3 of them. I make 4 of them, right? So it's always going to be a parabola going this way because we started with 0. We can't really go to negative patterns anyway, so we don't even need those arrows. So we're not going to, right? We're not going low in the amount of money we're making. We're going how high. What is the highest amount of money I can make? So we're looking at a parabola that is this shape, not this shape, because we're starting with 0 patterns and 0 money. 1 pattern gets us some money, 2 patterns gets us some amount of money. And each time we make more patterns, we get more money, right? How much money can we make? If that's the graph of the money I'm making on my patterns, right? How much money can I make? I can make that much money. It's the most money I can make. Good? I don't know why. I don't know what's wrong with these patterns that after you get to that point, you start losing money with every pattern. But anyway, it's the information they gave us. So we want to find the most amount of money, right? Y is money. What's the most amount of money I can get? That's just my vertex. So all we're doing is we're finding the vertex. We just have some decimals as our A, B, and C. So we want to find the vertex of the point, sorry, the vertex of the equation y equals negative 0.002 x squared plus 3.5 x minus 600. What is the vertex? All right. Y equals negative 0.002 x squared plus 3.5 x minus 600. Good. We're going to find the vertex. The vertex is going to have an x and a y value, just like all our other examples. X is negative b over 2a. What is negative b? A is negative 0.002. B is 3.5. C is negative 600. Let's put those in. Negative b is a negative 3.5. 2 times negative 0.002. Multiply 2 times negative 0.002. And then take negative 3.5 and divide it by negative 0.004. $875. X. Is X my number of patterns? So I know X is 875. Was X my patterns or was X my money? X is my pattern. So we have 875 patterns. And how much money can they make if they sell 875 patterns? We just put that value into our original equation. So when we have made 875 of these, what is Y? How much money do we have? When we have 875 patterns, how much money do I have? Y equals negative 0.002 x squared plus 3.5 x minus 600. Good. First, I'm going to square 875. $765,625. 875 times 3.5 is $3,062.50 minus $600. Still need to multiply that number by 0.002. So we have, that was 875 squared, right? Multiply that by negative 0.002. Oh, it's negative money. Negative 1,531.25 plus 3,062.50 minus 600. What on earth? Is this not? I should make that mint. Okay. It's a lot of patterns. Negative 1,531. I guess I didn't have to type all that in again. Plus 3,062.50 minus 600. 931.25. All right, so we made 875 patterns and we earned $931.25. That's not great. I don't know, I guess I was imagining like a very intricate pattern of some kind. 931.25 is the most money they can make when they produce and sell 875 patterns a month. All right, for question 8, I just did it, but I didn't copy down the negative 2x squared. So I got it wrong. So I stopped the video and I'm just going to cut that back in. So there's a cut. 2x to the fourth plus 8x cubed minus 8x squared divided by negative 2x squared. When I made a mistake, I didn't make that a negative. All right, what we are doing is they're just asking us to find the quotient. I think the easiest way to do that is to separate it out into, it's one fraction right now, but I can separate it into three. So we have 2x to the fourth divided by that same denominator, negative 2x squared, plus, so that plus goes between them, 8x cubed divided by negative 2x squared. Here we have a minus between it. You can put the minus here and make that a positive 8x squared divided by negative 2x squared. But since the bottom's a negative, I think what would be easier is to just make that a plus and then make the 8 a negative. Negative 8x squared divided by negative 2x squared. So that negative went right here. But it's also perfectly fine to put that minus right here and make that a positive. Okay? All right, so let's take this piece by piece. We have 2x to the fourth divided by negative 2x squared. I'm going to put it into factored form. 2 is just 2. X to the fourth is x times x times x times x. Negative 2. I'm not going to say that negative 2's factored form is negative 2. I'm going to say it's negative 1 times 2. And then x squared. Because if I leave it as negative 2, it's not the same as a positive 2, and I cannot cancel them. All right? If this sign is positive and this is negative, I need to make it into that positive version of that term times negative 1 so that these cancel. If that stays negative 2, these do not cancel. They have to be exactly the same in order to cancel. Okay? So what cancels from the numerator and the denominator? A 2, an x, and an x. And what am I left with? X times x on the top and negative 1 on the bottom. Remember, anything divided by negative 1 just makes that term negative, right? 3 divided by negative 1 just becomes negative 3. X divided by negative 1 just becomes negative x. X squared divided by negative 1 just becomes negative x squared. Okay, so that first term has become negative x squared. Then we've got 8x cubed divided by negative 2x squared. Eight, the factored form of 8 is 2 times 2 times 2. Why? Because if you think about 8 in the factor tree of 8, it's 4 times 2. And 4 is 2 times 2. So 8 is 2 times 2 times 2. And then x to the third is x times x times x. On the bottom, we have negative 1 times positive 2 times x times x. And what can we cancel? We can cancel a 2, an x, and an x to get 2 times 2 times x divided by negative 1 again. So that's 4x divided by negative 1, which becomes negative 4x. That was that one. So that is now minus 4x. Last one. negative 8x squared divided by negative 2x squared. The negative 8 becomes negative, you could just say negative 2 times 2 times 2, right? Because the negative is just 1. There's just one negative term and the rest are positive so that the whole term is positive, right? Negative 2 times a positive 2 becomes negative 4. That negative 4 times a positive 2 becomes negative 8. If we make them all negative, they'll start canceling each other out, okay? So it's just a negative 2 times 2 times 2 times x times x. And here we just have negative 2 times x times x. There's a lot of different ways to look at that negative. Okay, but the important thing is that we don't just call each factor of negative 8 a negative. So it's not negative 2 times negative 2 times negative 2. You can even think of it as parentheses around all of them or a negative 1. We could also write it as, we could also write it as negative 2 times 2 times 2. Or you could think of it as negative 1 times 2 times 2 times 2 times x divided by negative 1 times 2 times x times x. Just make sure that you have one negative term or that everything at the end remains negative. You're not turning everything negative, okay? What cancels here? The negative 2's cancel because they're exactly the same. This negative 2 can't cancel with positive 2. It's only the negative 2's. And what are we left with? We have a positive 2 times a positive 2, which is 4. So that was that one, and it is 4. Now let's look at the sign. Oh, sorry, didn't see that. Let's look at the signs between them. All right, 2x to the fourth minus 2 divided by negative 2x squared becomes negative x squared, plus 8x to the third divided by negative 2x squared becomes negative 4x, plus negative 8x squared divided by negative 2x squared becomes 4. So all of these have a plus between them. So it is in fact negative x squared plus negative 4x plus 4. And then you can simplify that too. So that was negative x squared plus negative 4x plus 4. Negative x squared minus 4x plus 4 is my final answer. Good? Okay. Good. All right, they are asking us to find the quotient again. And this time we have 12x to the fifth plus 3x cubed plus 6x, and we're dividing it all by 9x cubed. Let's separate it out. We have 12x to the fifth divided by 9x cubed plus 3x cubed divided by 9x cubed plus 6x divided by 9x cubed, right? We'll just separate each of those out. 12x to the fifth divided by 9x to the third. I'm going to put that into factored form. 12, if I take 12 and make it into a factor tree, I get 3 times 4. So the factored form of 12 is 3 times 2 times 2. And then x to the fifth has 5 x's. 9 is just 3 times 3. Then I have 3 x's. What's going to cancel? One of the 3's will cancel. And 3 of the x's will cancel. And we will be left with 2 times 2 is 4. X squared over 3. Good. You can also write it as 4/3 x squared if you want. Next one is a positive 3x cubed divided by 9x cubed. 3x cubed divided by 9x cubed. That denominator is always going to have the same factored form, right? 3 times 3 times x times x times x. 3x cubed is just going to be 3 times x times x times x because there are no further ways to factor 3. So what cancels between the numerator and denominator? A 3, an x, an x, and an x. So what we have is nothing on the top and 1 3 on the bottom. You can't put a 0, can't put nothing. We put a 1. Okay, so it's just 1/3, no x. All the x's were canceled. So we have 4/3 x squared plus 1/3. Last one. 6x divided by 9x cubed. 6 is 3 times 2. 9 is 3 times 3. And then we have x cubed becomes x times x times x. What can we cancel? We can cancel a 3 and an x so that we have 2 over 3x squared. Good. So 12x to the 5th divided by 9x to the 3rd becomes 4/3 x squared. 3x to the 3rd divided by 9x to the 3rd becomes 1/3. And then 9x divided by 6x divided by 9x to the 3rd becomes 2 divided by 3x squared. All right. And pay attention that for this first one, the x was on the top. If it's on the top, you can put it next to it. But if that x is on the bottom, that does not go out next to it. That does not go behind it. It stays under the fraction bar, okay? So if you ever have x's under the fraction bar, that means we're dividing by the x squared. If the x is above the fraction bar, we're multiplying by the x squared. So it's really important to keep that x right where it's supposed to be, right? We factored out 3 x's from both the top and the bottom, so there should be 2 left on the top, which can also go next to it. Here we factored out 1 x, so there should still be 2 x's on the bottom, so it needs to stay on the bottom. So our final answer here is 4x squared over 3 plus 1/3 plus 2 over 3x squared, aka 4/3 x squared plus 1/3 plus 2 divided by 3x squared. So here the x is being multiplied, here it's being divided. It's being multiplied, so it's on the top. It's being divided, so it's on the bottom. All right, question 10. Divide using the long division method. So long division is just that elementary school skill. You take the bottom of the fraction, the denominator, you put it out in front of the house. I never leave enough room for the house. Because you put your answer up here and I never leave enough room. 12a cubed squared plus 13a plus 6. All right, so long divide, you take that whole term, 4a plus 3, and you line it up with 12a squared plus 13a, right? So you're looking at this whole thing compared to your first 2 terms, okay? So 4a, how many times does 4a go into 12a squared? What can I multiply 4a to get 12a squared? 4 times 3 is 12, right? And then a squared, 4 times 3 is the 12. A times a would be the a squared. Good? So if I took 12a squared and divided it by 4a, I would get 3a. Or To get up to 12a squared, I can multiply 4 times 3 and a times a. Good. I'm going to put that below. 4a times 3a is 12a squared. Now I have to do that 3a to the 3 as well. So 3a times 3 is 9a. Take that whole thing and we're subtracting it. Okay. 12a squared minus 12a squared, that is done. 13a minus positive 9a. 13a minus 9a. It's just 4a, right? Now, bring the next term down. Plus 6. All right, so now we're taking this whole thing again. 4a plus 3, and we're applying it to 4a plus 6. To go from 4a to 12a squared, we multiplied by 3. 4 times 3 is 12. A times a is a squared. To go from 4a to 4a, we just say positive 1. Okay? Now take that and apply that positive 1 to the 4a. 1 times 4a is 4a. 1 times 3 is positive 3, but we subtract it. Good. 4a minus 4a means that's done. 6 minus 3 is 3. So we have 3a plus 1, remainder 3. We know it's the remainder because there's nothing else to pull down. Okay? The way that this question wants you to write the remainder 3 is as the numerator over this denominator. Okay? So what we got was we got 3a and then we got a 1. But then we just had 3 left over. But it's not just the number 3 because it didn't end, right? It didn't end in 0. So it's 3 over 4a plus 3. Sorry, I forgot the plus sign. Good. So you have your first term, your second term, and your remainder goes over the original denominator. Okay, so when you get to the end and you have a remainder, just copy down your original denominator and put that remainder as the numerator. You're done. 3a plus 1 plus 3 divided by 4a plus 3. Good. All right, question 11 asks us to use synthetic division to find the quotient and specify the quotient and the remainder. If there's no remainder, enter 0 in the appropriate answer box. So you don't, so they've given you the denominator. You had to give yourself the denominator for question 10, okay? But it's just, they just took that number, put it at the bottom of a fraction with the remainder as the top of the fraction. All right, let's do some synthetic division. So we're taking 2x cubed plus 7x squared minus 3x plus 2, and we're dividing it by x plus 4. For synthetic division, that means x plus 4. X plus 4 is a factor, right? A factor of 2, or sorry, we're dividing it. We're dividing this by x plus 4. So x is actually equal to -4. Okay, so -4 is what's going to go outside. Then we're going to build our synthetic division box. Well, how do we build it? We take the 2 from 2x cubed. We take the 7 we take the -3 and we take the +2. I didn't need to put a plus there, but anyway, good. All right, so we have 2x cubed plus 7x squared minus 3x plus 2. We're dividing by x plus 4. So we took the x value, which is -4, put it right here, and then we're going to solve through synthetic division. 2, remember, just goes straight down, remains itself. So 2 remains 2. Now you bring that up, you multiply it by -4. 2 times -4 is a -8. 7 minus 8, combine these. 7 minus 8 is a -1. -1 times -4 is a +4. Combine -3 and 4 to get 1. Take that up, multiply it by -4. 1 times -4 is -4. -4 plus 2 gives me a -2. Good. So this is my remainder. Right? Because they gave me a spot for my remainder. So I know my remainder is -2. I'm going to put it right here. Okay. What do I do with the rest of these numbers? I have a 2, a -1, and a 1. Can I just put those right here? Sorry, can I just put those right here? No, right? You say, how do I put this back into this format? This is my constant, this is my x value, and this is my x squared. So I have 2x squared minus 1x plus 1, remainder -2. 2x squared minus x plus 1 plus -2 divided by x plus 4. Good. And if you don't like synthetic division, you can do it the long division method that we did for question 10. Another synthetic division problem. Here we have x minus 4. That means we have a +4 out here. X cubed becomes 1. -12x squared becomes -12. 48x is just 48. -64 is -64. Let's bring them down. 1 remains 1. 1 times 4 is 4. Combine -12 and 4 to get -8. -8 times 4, ugh. -32. -32 plus 48 is 16. Times 4 is 64. Oh, good. Whew. 64 minus 64 is just 0. So our remainder is 0. We're going to have 16. It's a +16, so that's a plus. -8 gets an x. There's not a plus between them because it's a -8. It could have been a minus. And then 1 gets an x squared. So we have x squared minus 8x plus 16, no remainder, which they want you to put as 0 over x minus 4. Good? All right. Question 13 asks you to use the factor theorem to find the real zeros for the polynomial function and one factor. All right, what I would do here is I would use synthetic division again, run a synthetic division rule. All right, so I would say we have the factor x minus 5, and we have f of x equals 4x cubed minus 19x squared minus 8x plus 15. So that would become 5 over here, 4, -19, -8, and +15, right? 4. 4 just comes down as 4. 4 times 5 is 15. Not. 4 times 5 is 20. -19 plus 20 is 1. 1 times 5 is 5. -8 and 5 is a -3. 5 and -3 is a -15. And so I get a 0 as my remainder. Good? Okay. So that means I have 4x squared plus x minus 3, right? Is one of my factors. And then my other is x minus 5. So the reason I did the synthetic division is to factor out that factor. So now I have 4x squared plus x minus 3. right? Now I just need to turn this into two other factors. Why? Because I have right here x equals, x equals, x equals. One of my factors I already know is x minus 5, right? If one of my factors is x minus 5, that means my answer is x equals positive 5, right? Because 5 minus 5 is 0. So x is 5 is one of my answers. Just put that in right now. You will get that credit for that answer, okay? I factored out that x minus 5 by doing synthetic division, or you can do long division, okay? However you prefer to divide, but you divided out the x minus 5 and you're left with 4x squared plus x minus 3. So here we would need a number that multiplies to equal negative 12 and adds to equal 1. Is there anything that multiplies to negative 12 and adds to 1? Yes, it is positive 4, negative 3, right? Positive 4 and negative 3 multiply to equal negative 12, but add to equal 1. So I'm going to do factoring by grouping, which I know was like a long time ago. But that positive x becomes positive 4x minus 3x minus 3. Good. And then I factor out, what can I factor out of this first group? We can factor out a 4x, and we are left with x plus 1. And in the second group, I have a negative 3x, so I know my answer is going to be negative. What can I factor out? I can factor out a negative 3. Negative 3x divided by negative 3 is x. Negative 3 divided by negative 3 is a plus 1. X plus 1 times 4x minus 3. So now I found those other two factor pairs, all right? X plus 1, 4x minus 3. I went from 4x cubed minus 19x squared minus 8x plus 15 to x plus 1 times quantity 4x minus 3 times quantity x minus 5. All right. Look at them again. We have x plus 1. We have 4x minus 3. And we have x minus 5. How did I do that? I did it through synthetic division to factor out the x minus 5. And then I had to do factoring by grouping to get 4x squared minus x, or sorry, plus x minus 3 to get that to x plus 1, 4x minus 3. All right, so here I'm just going to set it equal to 0 and solve for x. X is negative 1. Add 3. 4x equals 3. Divide by 4. Divide by 4. X equals 3/4. Here, x minus 5. Set it equal to 0. Add 5 to both sides, and we have x equals 5. So here are my three answers. X is negative 1, x is 3/4, and x is 5. It was intimidating, but doable, right? Those are all skills we used in previous questions. All right, here's another one. Use the factor theorem to find the real zeros for the given polynomial function and one factor. Answer exactly. So again, they give us 4x cubed plus 7x squared minus 55x plus 50, and they say one of the factors, so we need three factors, right? We need this guy. We need this guy. And we need this guy. One of them they already gave us. They already gave us x plus 5. We set that equal to 0. Subtract 5, and we get x equals negative 5. Done. Okay. That is one of the answers. To find these other two, we divide out the x plus 5. Okay. So one way to do it is just to say 4x cubed plus 7x squared minus 55x plus 50 divided by x plus 5, right? Or x plus 5, 4x cubed plus 7x squared minus 55x plus 50, do the long division, or, right? Or do synthetic division. X plus 5 means we're going to have a negative 5 right here. 4, 7, negative 55, 50. All right. Bring the 4 straight down. 4 times negative 5 is a negative 20. Let's see if I got it this time. Negative 20 plus 7 is 13. Oh no. 13 times negative 5. Negative 65. Oh, sorry, it's a negative 13. God, I was like, I don't want a negative 65. I want a positive 65, so it's just 10. 10 times a negative 5 is a negative 50, and then I get a 0 as my remainder, which is what I want, right? All right, if 0 is my remainder, then I say 10 negative 13x 4x squared, right? So now this, what I found by factoring out the x plus 5 is that 4x squared minus 13x plus 10 multiplied by x plus 5 will give me that, right? But I still need to factor 4x squared minus 13x plus 10. Can I divide anything out of those? I cannot. All right, so I need to multiply to equal 40, add to equal negative 13. I think it's going to be two negatives, right? So it could be 4, negative 10. It could be negative 7, negative 5. Oops, sorry, negative 8, negative 5. And that looks like it works, right? Negative 8 plus negative 5 is a negative 13. So we have 4x squared minus 8x minus 5x plus 10. So now I'm doing factoring by grouping because the A was not the number 1, right? A is 4, so we have to do factoring by group. Because A is not 1, we had to go to factoring by grouping. We did that by multiplying 4 times 10 and we got 40, so that we need two factors that multiply to 40 and add to negative 13. So we chose negative 8 and negative 5. When you multiply them, you get 40. When you add them, you get negative 13. So I rewrote 4x squared minus 13x plus 10 to 4x squared minus 8x minus 5x plus 10. Now, and you can switch them. It doesn't matter if you put the 8 here or here. You do need a negative sign in front of each of them. All right, so now that we've put these together, we're going to split them in two. We're going to take the first half, 4x squared minus 8x, and we're going to factor out the biggest common factor, which would be 4x, right? 4x squared divided by 4x would just leave us with x, and then negative 8x divided by 4 would leave us with negative 2, which we'll write as minus 2, all right? The other two, negative, don't forget to include that sign, negative 5x plus 10. So we know that that factor is going to be negative, and the biggest factor common to negative 5x and positive 10 is a negative 5 or a positive 5, but you want to keep it negative because that sign is negative. So that factor must be negative. 5x divided by negative 5x divided by negative 5 is just a positive x, and then positive 10 divided by negative 5 is a negative 2. And in that case, we have x minus 2 as a factor common to both of the terms. So we take out x minus 2. When we take out x minus 2 from 4x times x minus 2, we get 4x. And we take x minus 2 out from negative 5 times x minus 2, we get -5. All right, so we went from 4x cubed plus 7x squared minus 55x plus 50 to 4x squared minus 13x plus 10 times x plus 5 because we divided by x plus 5 because they gave us that factor. We then took 4x squared minus 13x plus 10, and using factoring by grouping, we factored it to x minus 2 multiplied by 4x minus 5. So we will put those there. So our three factors for 4x cubed plus 2x squared, 7x squared minus 55x plus 50 is x minus 2, 4x minus 5, and x plus 5. If you multiply all these together, you'll get back to the original f of x. Okay. Now they gave us this one, so we already solved it set it equal to 0 and solved it to x, and we got the factor x equals -5. For the next one, x minus 2, you're just going to set that equal to 0 and solve for x. So add 2 to both sides, and we get x equals 2. Good. And then over here, 4x minus 5, set it equal to 0. Add 5. 4x equals 5. Divide by 4. Divide by 4. X equals 5/4. So our answers are x equals 2, x equals 5/4, and x equals -5. If you were to graph this in Desmos, it would cross the x-axis at x equals 2, x equals 5/4, and x equals -5. So you can check your answer on this review using Desmos. All right, this says find all solutions to x cubed plus 4x squared plus x plus 4 equals 0 if x equals -4 is one solution. So this is similar to that question 14. Here they gave us a factor, one of the three factors. Here they're giving us one solution. The difference between a solution and a factor is that the solution is already set equal to 0. Or sorry, the solution already gives us the value of x. So when we were doing with this one, we took x plus 5, we solved for x to get that x equals -5, and then we put it into our synthetic division system, right? So we are going to skip the step of x plus 5 becomes -5, and the way x plus 5 becomes -5 is we set it equal to 0, and we subtract 5. X equals -5, and we put that over here. So instead of having to change from x plus 5 to x is -5, we just start at x is -4. All right. So for here, x is -4 for our synthetic division. We've got the numbers 1, +4, +1, and +4. All right. We're just going to bring that 1 straight down. 1 times -4 is -4. 4 combined with -4 gives us 0. 0 times -4 is 0. 1 combined with 0 is 1. 1 times -4 is -4. 4 and -4 combined give us 0. So there's no remainder. We have 1, we have 0x, and we have 1x squared. X squared plus 0x plus 1, because none of those were negative. Good. So here is we have factored out one of the solutions. So x cubed plus 4x squared plus x plus 4 then becomes x plus 4 times x squared plus 1. I'm just going to leave it like that because 0x doesn't need to be written. Okay, so we found one solution. Here is another solution, right? What would the value? I guess. Now, we know that one of the solutions is x equals -4, right? Because if we set that equal to 0, we'll get x equals -4. For this one, we're still at x squared, but we can set it equal to 0 because x squared plus 1. Can you factor that? Can you find something that when you multiply it, it equals 1, and when you add it, it equals, we don't have a b, so we'd have to say 0. Does anything multiply to 1 and equal 0 when you add it? No, because -1 and 1, -1 and 1 would not give you 1. They would give you -1. -1 and -1 would give you 1 when you multiplied them, but wouldn't add to 0. 1 and 1 do not add to 0, right? So you cannot factor this. You could put it into the quadratic formula if you want. You can also set it equal to 0 and then solve it that way. So you would subtract 1 from both sides. X squared equals -1. Take the square root of both sides, right? When you take the square root of both sides, you have to remember to put the plus and minus on the right side because we want every possible answer, right? So the square root of x squared equals plus or minus square root of -1. Square root of x squared just becomes x. Plus and minus means we're going to have two answers, right? And then the square root of -1. What do we know equals the square root of -1? It's kind of crossing into older topics, but it's I. All right. So x is -4. And because of this, x is -I and x is I. So those are our final answers because we factored out x equals -4. And what we were left with was x squared plus 1. The only way to solve x squared plus 1 is to use -I and +I. All right, question 16. Find all solutions to x cubed minus 5x squared minus 5x minus 1 equals 0 if x equals 1 is one solution. So we're just doing this the very same way. So we're going to start with synthetic division. X is 1, so we're going to put a 1 right here, make our box. We have 1x cubed, we have -5x squared, we have 5x, and we have -1. Good? The 1 comes straight down to give us 1. 1 times 1 is still 1. -5 combined with 1 is -4. -4 times 1 is -4. -4 and 5 is 1. 1 times 1 is still 1. -1 combined with 1 is 0. So that's our remainder. We have 1, we have -4x, and we have x squared, or 1x squared, right? 1x squared minus 4x, and that's a positive one, so I'm going to say plus 1, is a factor because we have factored out x equals 1. So the solutions are x equals 1, so that's already taken care of. That factor would look like x minus 1, but that does not matter. If that doesn't make sense, do not worry about it. Our other factor is this one. You can either write 1x squared, or I'm just going to write x squared minus 4x plus 1. You do need the 1 here because there's no x to represent it, right? We can say it's x squared or it's 1x squared, but if you don't have a variable, you have to include the 1. All right, let's see if we can't factor this. Now, based on how it's showing you, based on the answer box it's giving you, it's my guess is that it won't be factorable because they're using a number plus or minus the square root of another number. What does that remind you of in terms of answers? It reminds me of the quadratic formula, right? But we can look at it. So x squared minus 4x plus 1, I would, if I was to factor this, so remember what we want are two factors like that. So if I was to factor this, I would need to multiply to equal 1 because 1 times 1 is 1, and it would need to add to equal -4. Are those going to be any whole numbers I know of that multiply to 1 and add to -4? No. So I'm going to go to the quadratic formula. A is 1, B is -4, and C is 1. Where did I get those? here, oh, sorry, ax squared plus bx plus c, right? X squared minus 4x plus 1 means that a is x squared, 1x squared. B is negative 4. C is 1. All right. So those are our A, B, and C, and we're going to use the quadratic formula, which says, if I remember it, let me start over here. X equals, so we're using x squared minus 4x plus 1. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then we're just going to input 1 for a, negative 4 for b, and 1 for c. Based on a is 1, b is negative 4, c is 1. Right? I'm just going to write it down here. Run out of space. Negative b. What was b? Negative 4. So we're going to do negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 1 divided by 2 times 1. See where I got all those? So this is my A, right? We said A is equal to 1. A is equal to 1. So here, that would be here and here. So I put it here and here. We said B is equal to negative 4. B is equal to negative 4. Good. And then C is also equal to 1. B is equal to 1. Good. So that's where I got those. Now let's simplify. So this becomes negative times negative 4, or a double negative becomes a positive, right? So we can just call that 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 is just minus 4. 2 times 1 is 2. Let's continue simplifying. So that's 4 plus or minus the square root of 16 minus 4 is 12 divided by 2. So now we have 4 plus or minus the square root of 12 divided by 2. I need to simplify the square root of 12, right? So 12, I can factor it to 3 and to 4. Are either of those perfect squares? Yes. 4 is a perfect square. So 4 plus or minus the square root of, instead of 12, I'm going to say 3 times 4 divided by 2. And then 4 comes out as 2, right? Because the square root of 4 is 2. 2 square root 3 divided by 2. Good. I just realized that I was writing this for no reason, but I'll finish it. Ignore that I just wrote it twice. Now think about how we can simplify 4 plus or minus 2 squared root of 3 divided by 2. It looks like you can either separate it out, 4 divided by 2 plus or minus 2 square root of 3 divided by 2, Or you can just think about it and say, can I divide 4 by 2? Yes. Can I divide 2 squared root of 3 by 2? Yes. That simplifies to 4 divided by 2 is 2 plus or minus 2 square root of 3 divided by 2 is just square root of 3. So our factors are, I know that was a lot of work, but our factors are 1 and 2 plus or minus, they already wrote that for you, square root of 3. Oh, you couldn't see it because I didn't pull it down. Those 15 and 16 were very difficult. Good work. All right, 17. State the end behavior of the function. These are intimidating, but if you just think about, have a little table in your head, you will know what to do with them. So let's first just read question 17. State the end behavior of the function when f of x equals x to the power of 11. As x approaches negative infinity, f of x approaches what? As x approaches infinity, f of x approaches what? Okay. What are they asking? As x approaches negative infinity is simply, here's our graph. As x approaches negative infinity, is that what it starts with? As x approaches negative infinity just means this way on the graph. So we want to picture this as a three-dimensional image. Two-dimensional image. Two-dimensional plane, okay? As x approaches negative infinity means that way on the x-axis. All right? As x approaches positive infinity, we want to look at that way on the y-axis, all right? So as x approaches negative infinity just means when we're going this way on the x-axis. As x approaches positive infinity, which just means as we go this way on the x-axis, all right? And f of x is y. So as we are going this way, as x is approaching negative infinity, as we are going that way, is y going up or is y going down? So there are really only two options for as x approaches negative infinity, f of x approaches. We're either going to put infinity or negative infinity. As x approaches infinity, f of x is either going to be negative infinity or infinity. So there's only 4 real combinations that you are choosing between for these type of questions, okay? The answer to the question has to do with the leading coefficient. If I knew this distance. So it has to do with the leading coefficient of the function. Tilde. That's right. Okay. So we either have all right, so we've got our degree of the function, the leading coefficient of the function, and then which way or the end behavior, I guess you could call this. There are only 4 options for degree. There are only 2 options for degree. There are only 2 options for leading coefficient. And so the combinations possible, there are 4, okay? So by the degree, we mean this number, right? Is the degree an even number or an odd number? So we have even numbers and we have odd numbers because you're not going to get 0. Okay, and the even and odd degrees determine whether the function, an even degree, will always either open up or down. Okay, even degrees will always open up or down. So we know that the parabolas we've been looking at have been x squared, right? We know that x squared is always either going to look like this or like this, right? X cubed is odd because that's the number 3 is odd. The power is odd. So odd degrees or odd functions are either going to look like that or like that, like x cubed. And feel free to go into Desmos and graph x cubed and x squared. So if you've got an odd function, the degree is odd, you're not up like a cup or down like a frown. You're just going across, right? The end behavior would be here. For an even function, the end behavior is both ends are going up or both ends are going down. For an odd function, the end behavior is one end is going up, the other is going down. One end's going up, the other end's going down. One end's going up, the other's going down. Going up, the other one's going down. You just want to match that with a symbol, right? Because this would be negative infinity if I had to put a symbol with that, right? This would be infinity. This would be infinity because we're talking about the y-axis. This would be negative infinity, right? This one, we're going towards negative numbers on the y. Here we're going towards positive numbers on the y. Here we're going towards negative numbers on the y. Here we're going towards positive numbers on the y. Here we're going towards negative numbers on the y. Here we're going towards negative numbers on the y. Here we're going towards positive. On the left, we're still going towards positive. Negative, negative, positive, positive. All right. So when you see both ends going up, we're approaching infinity. Both ends going down, we're approaching negative infinity. Approaching infinity, approaching negative infinity. This one would be approaching infinity as x approaches infinity, approaching negative infinity as x approaches negative infinity. This one would be approaching infinity as x approaches negative infinity. This one would be approaching negative infinity as x approaches infinity. Good? And then if the leading coefficient, so that number next to the degree, in this case, the number is just a 1, an invisible 1. So if the leading coefficient is a positive number, then it will always go up. Good? So that means as x approaches infinity, f of x approaches infinity. As my x goes this way, because as x approaches infinity means we're going that way. As we go that way, f of x goes that way. As x approaches negative infinity, f of x also approaches infinity. As x approaches negative infinity means this way on the graph. Y is still going up. It's going up that way, and it's going up that way. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y still approaches infinity if their degree is even and your leading coefficient is positive. If your degree is even and your leading coefficient is negative, the only other option, right? What are you doing? You're going down like a frown. That means as x approaches infinity, y approaches negative infinity. As x approaches infinity, y goes down. As x approaches infinity, y goes to negative infinity. As x approaches negative infinity, f of x approaches negative infinity. As x approaches negative infinity, y goes down. As x approaches infinity, it goes that way, y goes down. All right, the odd ones, notice if it's an even degree, you have both the same answer, both negative, both positive, if it's an even degree. This case, we have an odd degree. An odd degree means it's either going to look like this, or it's going to look like this. All right, so one of these is going to be negative infinity, the other is going to be infinity. Right? Because it's odd. It's odd, so it's going to make this shape or this shape. Okay? Odd. If it's positive, it's always going to go like this as an end behavior. Yeah? As x approaches infinity, so as we go that way, as x gets bigger, y gets bigger. As x approaches infinity, y approaches infinity. As we move the other direction on x, as x approaches negative infinity, y approaches negative infinity. So x approaching negative infinity means going this way on the graph. As x approaches negative infinity, y also approaches negative infinity. Okay, so these are the two possibilities for odd. When odd is positive, the only possibility is this one. Okay, not this one. Finally, if we have odd and our leading coefficient is negative, it will always be doing this. Okay? As x approaches infinity, y, so as x approaches infinity, what's y doing? Y is approaching negative infinity. As x is approaching negative infinity, y is approaching infinity. Good? So we know our little table, or we can just picture f of x equals x to the 11th. So it's not negative, it's a positive leading coefficient. So it's either a smiley face or it's an, what would that be? It's going up. It's going up from left to right if I was reading it. So it's either a smiley face or it's going up because it's positive. Positive. Your two options are up or up. They're both going up to the left, right. Now, odd means that or that. So positive means it's either a smiley face or it's going up to the right. Odd means it's either going up to the right or down to the right. So the only one that is common to both of them is this guy. This guy, if we think about it, as x becomes negative infinity, as we go this way, what is y doing? Y is going down. As we go this way along x, y goes down. As we go this way on x, what does y do? Y goes up. So he's going up as x gets bigger, and he's going down as x gets smaller. As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. All right, next one. He is also positive, but this is an even degree. Positive leading coefficient means it opens up to the right. So it's either this one or that one. This is an even degree. The even degrees are either up like a cup or down like a frown. So then we say, okay, which is the only one that is common to both of them? This guy. And then we think about what he's doing. So here's my x. This is negative x. This is positive x. Here's my y. Here's my positive y. Here's my negative y, right? If I just put this guy on here, anywhere, it doesn't matter where. As x approaches negative infinity, so as we go this way towards negative x, as we go this way, what does y do? Y goes up. Up means infinity. As x approaches infinity, so as x gets bigger, what does y do? Y is getting bigger. Good. All right, so it's a lot of understanding how the system works, but then once you understand it, you can get through the questions quickly. One more end behavior. The longer one, but don't worry, the only part you need to focus on is the very first or leading term. So none of this is going to change the end behavior, okay? 5x to the fourth is my degree. You can start with degree or leading coefficient. It does not matter. Is your degree even or is your degree odd? Those are your only two options. This degree is the 4. 4 is an even degree. Even degree means it's either up like a cup or down like a frown. Good? It's not odd, so it will not be either of those. Now, is the leading coefficient, is number 5 positive number or negative number? It's a positive number. So the positive options are it's going up to the right like that, or it's going up to the left and to the right, which is the only one that's common to both of them. This guy, okay? We'll put him on an XY axis. Here is as x approaches negative infinity. Here is as x approaches infinity. Here is as y approaches negative infinity. Here is as y approaches infinity. Good? Because we know this is x. We know this is y. Right? Put our little up like a cup on there. As we go towards negative infinity on x, we're going towards positive infinity on y. As we go towards positive infinity to x on the x-axis, we go towards positive infinity on the y-axis. Good. All right, question 20, we're changing it up. This does, I think, look a bit intimidating, but do not worry. All right, so what we have is f of x equals x cubed plus x squared minus 25x minus 25, and we need to find three x-intercepts. All right, f of x equals x cubed plus x squared minus 25x minus 25. Good. All right. Can you factor anything out of all of this? Nothing is common to all four parts, right? But we can factor by grouping. I can just take this bit and say, I'm going to factor out an x squared. X squared, x cubed divided by x squared is just x, and then x squared divided by x squared is just 1. Here I have negative 25x minus 25. Remember, if this has a minus sign, we're going to make sure that the factor also is a negative. Negative 25x and negative 25, you can factor out a negative 25 and you get x plus 1. So now I have the factor pairs, x plus 1, and what is left over when I factor out x plus 1? X squared over here and negative 25 over here. Good? So one of my pairs is x plus 1, the other one is x squared minus 25. You are welcome to do it however you would like. You can set it equal to 0, right? You can say x squared minus 25 is 0. X squared equals 25. Take the square root of both sides, sorry. When you take the square root of both sides, you have to say plus or minus, and we say x is equal to plus or minus 5, which we would write as x equals 5 and x equals negative 5. You do it like that. And then here, we would set that equal to 1. Set that equal to 0. Subtract 1. X equals negative 1. So my answers would be x equals 5, x equals negative 5, and x equals negative 1. So you can do it like that, or you can just say, oh, I know, I recognize this, and then that's going to factor to x plus 5 and x minus 5. Why does it factor to x plus 5 and x minus 5? Because we need two numbers that multiply to equal negative 25 and that add to equal 0. And so those two numbers would be negative 5 and positive 5. So x squared minus 25 factors to x plus 5 times x minus 5. So one of our factors is solved by setting this equal to 0. And then our other two factors are solved by setting this equal to 0 and this equal to 0. The x-intercepts are negative 1, negative 5, and 5. Here we have x cubed minus 9x squared plus 18x. This is another one that starts with x cubed, which can seem intimidating. But what we're going to do is we're going to look at it and we're going to say, notice, what do you notice? Can I factor anything out? I can factor out an x. So what we would do is we would set it equal to 0. Well, we don't need to do that. I just need to not write that. What can I divide out of this? I can divide out an x, right? And now it's x. X cubed divided by x is going to give me x squared. Negative 9x squared divided by x is going to be minus 9x. And then positive 18x divided by x is just going to give me 18. So one of my factors is x. and then x squared minus 9x plus 18. I'm going to try to continue factoring that. What are two numbers that multiply to 18 and add to negative 9? Multiply to 18 and add to negative 9. I would say it would be 6, negative 6, and negative 3. Yeah? All right. So that means x squared minus 9x plus 18 becomes x minus 6 times x minus 3. And don't forget this x over here. Okay, so those are our three factors. We've factored it. They're asking for the x-intercepts, but we have found factors. So to find an x-intercept from a factor, we set each factor equal to 0. So x equals 0. Done. X minus 6 equals 0. Add 6. X minus 3 equals 0. Add 3. X equals 3. So our answers are x equals 0, x equals 6, and x equals 3. The reason they gave you a point is that they're on the x-intercept, so the y value is going to be 0. So it's going to be x is 0, y is 0, x is 6, y is 0, x is 3, y is 0. Good. Find the zeros and give the multiplicity of each. List the zeros in order from least to greatest. All right, for multiplicity, remember that the 0 is what you are finding here. The x-intercept is also the 0. Okay, so you're finding the x-intercept. How did we find the x-intercepts? Well, for number 20, right, we took factors. We took x cubed plus x squared minus 25x minus 25. We factored it to x plus 5 times x minus 5 times x plus 1, right? Or times x plus 1 times x squared minus 25, which we changed to x plus 1 times x plus 5 times x minus 5, right? Those are the factors. If you take them, set them equal to 0, and solve for x, you get your zeros, okay? So let's look at our three options here to find the zeros. One of our factors is x squared. If I set x squared, if I just take that part, x, and set it equal to 0, 0 is at x equals 0. It's done. Good. Next one is x plus 5 to the fourth. We're going to ignore the power, okay? Just take the x plus 5, just like here we just took the x, set it to 0, solve for x. Subtract 5, subtract 5, x equals negative 5. Sorry, it did say to put them in order from least to greatest, so I didn't. And then last one, x minus 1 to the power of 3. Just take the x minus 1, set it equal to 0, add 1, x is 1. So this is going to be in the wrong order from least to greatest. You would have to switch those to technically get it correct, but remember, so I don't think you would get full credit if you put it in the way I'm putting it in right now. All right, so we found the zeros because we took each factor. 0 is the factor of x squared. Negative 5 is the 0 of x plus 5. And 1 is the factor of x minus 1. We have the zeros. Now, for multiplicity, all you do is look at the power of the factor. That's a multiplicity of 2. Negative 5 was the x plus 5, so it had a multiplicity of 4. And then 0 at 1 was x minus 1. It has a multiplicity of 3 because it's a power of 3. You're done. Good? Well, except I put them in the wrong order. One more time, give the zeros and multiplicity of each. List the zeros in order from least to greatest. So remember, zeros are just taking, well, separating them out, right? Here's one of the factors. X plus 5 to the fourth is one of the factors. The other factor is x minus 2 squared. All right, I'm going to ignore the power and just say x plus 5 equal to 0 and solve for x. And I get x equals -5. X minus 2 squared. Set it equal to 0 without the squared. Solve for x. And I get x is 2. Now that I have both of them, I can put them in 0 at 2. No! Least to greatest. It's a -5. All right. 0 at -5. 0 at 2. The 0 at -5 has a multiplicity of 4. The 0 at +2 has a multiplicity of 2 because it was related to this one. This has a multiplicity of 4 because it was related to this one, and that's a power of 4. Power of 2. Good? All right. Now we're just going to look at some graphs. Use the polynomial function graph below to answer the following questions. What are the x-intercepts as a list of points? So remember, an x-intercept has a y of 0. We list points as x comma y. So this is going to be the point -6 as our x. It's crossing the x-axis, so our y is always 0. This one is going to be -3, 0. And it does not cross anywhere else. So it crosses the x-axis here, crosses the x-axis here. So those are the x-intercepts as a list of points. -6, 0, and -3, 0. Find the y-intercept as a point. It literally just tells you the y-intercept. The x is always going to be 0, and it crosses at 17, so that's the point 0, 17. Is the leading term odd or even? Go back to that table we made for the infinity symbol, if you can find it. Is the power of the leading term, is the power, which means degree. So is the degree of the leading term odd or even? So if it was even, it would be going up or down. If it was odd, it would be going down to one side, up to the other, down to one side, up to the other. Okay? Is this going up? Is this going down? Is this going up from left to right, or is this going down from left to right? This one. So the degree is even. The degree is even. And the leading coefficient, what is the sign? Just, is it positive or negative? Okay. So we've determined it's this, it's even, right? So is it going up or is it going down? It's going up, so the leading coefficient is positive. Same thing, find the x-intercepts. Remember, the x-intercepts is where it crosses the x-axis. Where does it cross the x-axis? Right here and right here. So those are the points. X -2, y 0. X +2, y 0. Good. What is the y-intercept? Is where it crosses the y-axis. That's just going to be 0, 0. It crosses at the origin. Is the power of the leading term odd or even? Is it even or is it odd? It's odd. Is it positive odd or negative odd? It's positive odd because it's going up from left to right. Positive because it goes up from left to right. And we said it's odd because it changes directions, right? Starts at negative infinity, goes to infinity. If it was even would just be up or down. Odd starts down, goes up, starts up, goes down. Find the x-intercepts and write as a list of points. There are no x-intercepts. What does XYZ like you? How does XYZ like you to explain it? DNE. It never crosses the x-axis. What is the y-intercept? It's right here, so that would be -8. It has to be as a point. Our x is 0, our y is -8. Good. Is the power of the leading term odd or even? So remember, odd looks like x cubed, which will always look like this, or this. Even is going to look like x squared or -x squared. So does this one look odd or even? It looks even. What is the sign of the leading coefficient? If the sign is negative, we are going down from left to right or down forever. Positive, we are going up from left to right or up in both directions. So it's going overall, right? It's doing one of these. So it's even and it's negative. All right, choose the graph of the following equation. This is the graph of y equals -9 over x. It is a reciprocal function. The parent reciprocal function is y equals 1 over x, and that looks like this. Why? Because it can never be 0. 1 divided by 0 is not a number, so that's not going to be on the graph, okay? Let's compare this to this. What's the difference? We still have x at the bottom in the denominator of the fraction, so it cannot be 0, right? -9 divided by 0 is not a number. So any graph that has a value for x equals 0, it cannot be that one. So it cannot be this, and it cannot be this, because if we put 0 in for x, y equals -9 over 0, it's not a real number. All right, so it's either this one or this one. They both look like some version of the reciprocal function, right? I think if I saw a good point on here, I would just put the x value in there and see if it was close, right? So if I put x equals 2, right here, and I'm trying to decide between these two graphs, is the answer going to be close to +4, or is this answer going to be close to -4, right? When x equals 2, y equals -9 divided by, instead of x, we're putting in +2. When x is 2, -9 halves is a negative number. -4.5. So when x is a positive 2, y is negative 4.5. 2, oops, sorry, 2, negative 4.5. Is that going to be on this graph or is that going to be on this graph? This one, right? So here's 1 over x. Because it's a negative 9, it got flipped. The negative sign made it flip to over here. And then the 9 moved it out a bit. That's how I would do that one. Use the given transformation to graph the function. The reciprocal function shifted right 1 unit and up 3 units. This is kind of hard to see because it's on 2 different pages. All right, which one of these is the reciprocal function shifted right 1 unit and up 3 units? Right 1, up 3. So the original reciprocal function I can fit over here. The original reciprocal function looks like this, right? It's never going to go through the intercept, the origin, the x and y intercept. Now they want it to shift it right 1 unit. So now instead of never going through the origin, it's never going to go through negative 1 x. Does this one go through negative 1 x? Get my ruler. So for the reciprocal function, we're never going through x equal y equal x equals 0, right? We're never going through x equals 0. If we move it right 1 unit, did I get my rights and lefts mixed up? If we go right 1 unit, it needs to never go through here. Change colors because that was wrong. Okay. Right 1 unit is this green dot, right? Left and right. I'm really bad at left and right. So now instead of never going through the origin, it's never going to touch x equals 1. So let's mark x equals 1 on each of those graphs. And see if it crosses any of them, right? It clearly crosses this one. And it clearly crosses this one. I'm not really good at drawing, so it could be not touching this one. It could be not touching that one, right? I wouldn't say it is, but all right, shifted 1, right 1 unit and up 3 units. So now we have the graph. Right 1 unit now looks like this. This guy is gonna cross the origin, okay? He's still not gonna cross up here, but he's gonna go like that. Then over here, he's gonna go like that. So that's right 1 unit. Now we need to go up. Is that what it says? Up 3 units. So notice that this was never crossing at x equals 0. It was never crossing. Now it's never going to cross y equals 3. Okay. Which one of these never crosses y equals 3? This one never crosses y equals 3 and never crosses x equals 1, which was a shift right 1, up 3. Next says find the domain of the rational function. The domain is anything, all values of x. Domain is all x values, okay? So what can x be? X can be anything, but it cannot be anything that would make the denominator of a fraction 0, okay? So we're going to take just the denominator, x squared plus 3x plus 2, and we're going to say this cannot be 0. Any x value that makes this equal to 0 is not allowed. So x is all real numbers, but x cannot be, and there are two answers, okay? How do we find those two answers? We factor x squared plus 3x plus 2. So we would need two numbers that multiply to equal 2, add to equal 3, right? Multiply to equal 2, add to equal 3, I would just say it's 2 and 1, right? X plus 2, x plus 1 equals 0. So we took the denominator, we factored it to two factors, we set those each equal to 0. So x is negative 2, x is negative 1. Now, if we used either of these, we would get 0 for the bottom, and that would be impossible. Okay, so x cannot be negative 2, x cannot be negative 1. Done. That is the domain. All real numbers except negative 2 and negative 1. State the domain for f of x equals x minus 5 divided by x squared minus 25. Again, we're just going to take the denominator, set it equal to 0. If I factored that, it would be x plus 5 times x minus 5 equals 0. Set each of them equal to 0. X plus 5 equals 0. Subtract 5 from both sides, and x cannot be negative 5. X minus 5 equals 0. So add 5 to both sides. X is 5. Those are the two answers x cannot be. X cannot be negative 5. X cannot be 5. Good. For question 31, they have given us another rational expression and asked us to find the intercepts and vertical asymptote for the function. X-intercept and y-intercept, we're just doing the same way we always do x and y-intercept. So to find the y-intercept, set x equal to 0. So we have f of x, which I'll just call y. Y equals 2. Instead of x, I'm going to put in 0 plus 4 divided by 3. Instead of x, I'm going to put in 0 plus 1. Simplify that. 2 times 0 is 0 plus 4. 3 times 0 is 0 plus 1. So that's 4 over 1, which is 4. So the y-intercept is 0 for x, 4 for y. X-intercept, we put in 0 for y, which is harder. So we had y equals 2x plus 4 over 3x plus 1. Now we're going to say 0 equals 2x plus 4 over 3x plus 1. Make this as easy on yourself as possible, right? You have a fraction. What do you do with a fraction when you're trying to solve for x? You multiply by both sides by the denominator. So I'm going to take all of this and multiply it by 3x plus 1. You might be like, but then I have x's on both sides. But it's okay. It's more okay because 0 multiplied by all of that is still 0. Right? So that will cancel on this side and leave you with simply 2x plus 4. And then if you take 3x and multiply it by 0, you still get 0. And 1 times 0 is still 0. So you still have 0 on this side. 0 equals 2x plus 4. Keep solving by subtracting 4. Negative 4 equals 2x. Divide by 2. divided by 2, -2 equals x. Good. So my x-intercept is -2, 0. My y-intercept is 0, 4. Vertical asymptote. To find the vertical asymptote, take the denominator, solve for x. That's all you have to do. All right, so the denominator is 3x plus 1. Set it equal to 0. Solve it for x. Subtract 1. 3x equals -1. Divide by 3. Divide by 3. And we get x is -1/3 as my vertical asymptote. Good. Question 32 says find the domain, which we've done, find the vertical asymptote, which we've done, and then the horizontal asymptote. So remember, let's just start with the domain. For the domain, x is all numbers, except x cannot be anything that makes the denominator 0. So take that denominator, set it equal to 0, and then solve for x. X squared minus 9 becomes x plus 3 times x minus 3. X plus 3 equals 0 means x is -3. X minus 3 equals 0 means x is 3. So x cannot be -3 or 3. Vertical asymptote. Remember, you just take the bottom and you solve. Set it equal to 0 and solve for x. Okay? Add 9. X squared equals 9. All right, I was wondering why I was about to get 2 answers. So I was going to square that, and it would be plus or minus x equals -3 and 3. But it only gives you room for one answer. And that is because I did not first simplify. So make sure you simplify first. Y equals x plus 3 divided by x squared minus 9. Factor the bottom. X plus 3, x plus 3, x minus 3. And then cancel out anything common to both of them. And we get f of x equals to 1 over x minus 3. And then set it equal to 0 and solve for x. So now we have x minus 3. Set it equal to 0, solve for x. X is 3, our vertical asymptote. Sorry about that. And then horizontal asymptote at y equals. Horizontal asymptote, you look at the leading coefficient and the leading degree, okay? So unsimplified, again, unsimplified, we had x over x squared. You only need those two. We have x to the power of 1 over x to the power of 2, right? This power of your numerator, if it is smaller than the power of your denominator, it's at y equals 0. If it is bigger than your denominator, there is none. And if they are equal, then you make a fraction of the two numbers. Good, but they're not equal. So you would be, well, not relevant right now. I don't want to create an example and create more work. So the horizontal asymptote, 1 is less than 2, so it's at y equals 0. Good. Which graph represents y equals 3 divided by x plus 3? Sorry, couldn't read it. Y equals 3 divided by x plus 3. You have 4 graphs here. You can look at them and decide. What I would do is I would pick a point where pick an x value that all of them cross at different spots, right? And maybe 0, right? When x is 0, this crosses here. This crosses way up here. This crosses here. And this crosses here. So those two are similar, but not the same. Sorry, you couldn't see that. This one and this one are kind of close. This one and this one are not close. That's Y equals 2, it looks like. Y is approximately 1. Y is approximately -1. And then this would be Y is maybe 1, -1/3. All right, so I would just take 0 and put it in for X and see which of these I got. -1/3, 2, 1, or -1. Y equals 3 over 0 plus 3 instead of X, right? 3 over 3, which is a +1. So I would pick this graph. You can do the same with this one if you want. 6 over X. They're all going through X equals -1. So Y equals 6 over X when X equals -1. What is Y? Okay, and then find Y. So Y equals 6 over -1, which is -6. Which one of those crosses X equals -1 at -6? Y. This crosses right here. This crosses up here. This crosses here. This crosses way up here. Oh, they're both at -6. All right, so it's not these two. And then do I think it's going to be shaped like this or like this? Well, let's do one more trial, right? When X is 0, does it not exist or is it equal to 0? Y equals 6 divided by 0. That is not a real number. It's impossible. So it cannot have crossed the origin. All right, guys, we did it. Thank you so much. And email me if you have any questions.